so that when you see some other things, you know exactly what to do. So let's just start off with a slightly larger alkane. So this alkane has 2 carbons bonded with a single bond, and each one bonds to 3 hydrogens so that each carbon has its 4 bond need. So because this is a 2 carbon parent chain linked together with a single bond, we know between table P and Q that this is simply ethane. So here we go. I am going to put this ethane through a substitution reaction, and I am going to replace one hydrogen with an OH. So this this hydroxyl group, the OH, it's going to come in and kick that hydrogen out. So here we go. We have our first carbon. It still has its 3 hydrogens attached to it. We have our second carbon. It still keeps 2 of its original hydrogens, but the third hydrogen has been replaced by that OH. So remember, that bond has to be shown between the oxygen and the carbon, and just kind of put it off at a slight angle to make sure. So like the example we did just above, we know that this is not pure ethane. Okay, so it's not pure ethane because we have that OH on there. So we have to eliminate the E and replace it with OL. So this structure's final name would be ethanol. Its condensed structural formula, practice those. Carbon 1 would be CH3. The second carbon, the hydrogens that are attached to it first, which are 2 of them, followed by that OH. And when you do that condensed formula, you see that sequence of HOH. Okay, so now I am going to put this through a second substitution reaction. So I'm going to replace one of these hydrogens with another OH. So this OH is going to come in and it is going to replace that hydrogen. So when I draw the structure, I still have my 2 carbon chain. Carbon 1, it still has its 2 hydrogens. The other carbon still has its 2 original hydrogens. This carbon now has its newly attached hydroxide, and the other carbon still has the first substitution present on there. So this, following like what we did here just above in the previous video, okay, 2 carbon, single parent chain, single bonded ethane, and we have ethane all. So instead of writing out ethane all, we would make it ethane. Instead of all, we would put in that di. All. Meaning we have 2 hydroxyl groups on the parent chain. Okay, so now I'm going to come over and I'm going to take our first ethanol structure and I'm going to put it through a different substitution. I'm going to add an OH, okay? And this OH is going to come in and it is going to replace that hydrogen. So now, this one, with its first substitution and with a new second substitution, we still have a carbon to carbon single bond, okay? Our first carbon still has its original 3 hydrogens. Our second one, it has still 1 hydrogen. It has its first substitution, OH, and now it has its second substitution, OH. So like before, this is ethane, 2 carbon parent chain, single bond, so ethane. We drop the E and we put all. So instead of saying ethane all, we also say ethane diol. So we have 2 structures that are ethanediols, right? But when you look at them, their structures are not absolutely identical. There are differences. So that means we need to do the location thing to differentiate them in their name. So when you look at the first one up here, okay, the red OH would be on carbon 1 and the black OH would be on carbon 2. When you look at it right to the left and you renumber, the black OH is the first one we come to, that's on carbon 1, and the red one is on carbon 2. So in this one, whether you look at left to right or right back to left, you come up with the same number designation. So here we go. Out in front of this ethanediol, we have to put, because there are 2 OLs, we need 2 designation numbers. So we put 1, 2 ethanediol. When we come down and look at our other example here, sorry, I'm still sick. Number your carbons left to right. When we look at this left to right, the black OH is on carbon 2. The green OH is also on carbon 2. Renumber your carbons right back to the left. Black OH left is now on carbon 1, and the green is also on carbon 1. So the number designation looking right back to the left, 1,1 is a lower combination than 2,2. Because it says di, you need 2 number locations, even if they're on the same carbon. So out in front, we have to put 1, 1 ethanediol.